Given the graph of the polynomial function below, we want to determine the smallest degree possible, the left and right hand behavior, determine whether the degree of the polynomial is odd or even, determine whether the leading coefficient is positive or negative, determine the number of turning points, as well as the zeros and their multiplicity. Let's first analyze the graph. Notice there are 3 x-intercepts. 1, 2, 3. From left to right we have -3, 0, 1, 0, and 4, 0. And notice the y-intercept is 0, -1. From left to right the graph goes downhill, uphill, downhill, and then uphill, which indicates the function is decreasing, increasing, decreasing, and then increasing. Let's begin by stating the zeros. The zeros are the x values for which y, or the function value, is 0. We determine the real zeros by determining the x-intercepts. This indicates the zeros are x equals -3, x equals 1, and x equals 4. Notice that the zeros of -3 and +4, the graph simply passes through the x-axis without flattening at all. This indicates the zeros of -3 and +4 have a multiplicity of 1. However, notice that the 0 of x equals 1, the graph is tangent to the x-axis, or it touches the x-axis and bounces back. This indicates the multiplicity is even. We will assume the multiplicity is 2. Let's discuss a little more about multiplicity. Again, if the graph passes through the x-axis at the 0, the multiplicity is odd, but if it passes through and flattens like we see here below, the multiplicity is odd but more than 1. For example, here is an example of a 0 with multiplicity 3. And if the graph is tangent to the x-axis or touches the x-axis and bounces back, we have an even multiplicity. Here's an example of multiplicity 2, where it simply touches the x-axis and bounces back. But if it behaves in this way but also flattens, the degree is still even, but more than 2. For example, here's a graph where the 0 has multiplicity 4. Notice the sum of the multiplicities is 4, which gives us the smallest possible degree. It could be more than 4 because we could have complex zeros which don't appear as x-intercepts. Only the real zeros appear as x-intercepts. And now let's determine the left and right hand behavior. The left-hand behavior is, as x approaches -infinity, what is y or f of x approaching? As x approaches -infinity, we can think of moving left along the graph. As we move left, notice the graph goes up, which indicates y, or the function values, increase without bound and approach positive infinity. The left-hand behavior is, as x approaches -infinity, y approaches positive infinity. The right-hand behavior is, as x approaches positive infinity, what is y or f of x approaching? As x approaches positive infinity, we can think of moving right along the graph. As we move to the right, or as x approaches infinity, notice the graph goes up. Once again, the y values or function values increase without bound, and f of x or y approaches infinity. The right-hand behavior is, as x approaches positive infinity, y approaches positive infinity. From here we should recognize for the left and right hand behavior, if y or f of x are both approaching positive infinity, that the degree is even and the leading coefficient is positive. For a quick review, looking at the table here on the left, if for the left hand behavior f of x approaches positive infinity, and for the right hand behavior if f of x approaches positive infinity, then the degree is even and the leading coefficient a is greater than 0 or positive. Which answers the next two questions. We now know the degree of the polynomial shown in the graph is even and the leading coefficient is positive. And for the last question, how many turning points does the polynomial have? Turning points occur where the function changes from increasing to decreasing or decreasing to increasing. Analyzing the graph, at this point, the graph changes from decreasing to increasing. This is a turning point. The graph changes from increasing to decreasing at this point, which is a turning point. And then finally at this point, the graph changes from decreasing to increasing, and therefore we have another turning point. We have 1, 2, 3 turning points. We may also notice that the turning points we either have a relative max or a relative min. I hope you found this helpful.